LangGraph end does not mean memory is erased. In this video, we will cover the whole graph first, define what end means, then use a small help desk example to show why every path to end needs a deliberate state decision. The core idea is simple: nodes write state, conditional edges choose paths, and end may checkpoint whatever state arrived there. Here is the whole workflow. A user asks a vague question. The graph starts the turn, routes the request, and may ask a clarification. If the user answers clearly, the graph searches the manual and answers. If the user stays vague for too long, the graph stops with a safe fallback. Both the ask path and the fallback path can end the current run, but they should not save the same state. In LangGraph, end is a control flow marker. It says, this graph invocation is done. It does not say, clear every field. If checkpointing is active, the state that reaches end can become the saved state for the next turn. Think of the graph as three jobs. Node functions write state. Conditional edges read state and choose the next path. End saves the result when persistence is enabled. That means the developer has to design what each path leaves behind. Imagine a printer manual support bot. The user asks, how do I save this for later? That is too vague. The bot should ask what item the user means, such as a scan preset, print profile, or network setting. On the first vague turn, the graph asks a clarification and then reaches end. This path should keep pending state. Pending clarification is true, the question text is saved, and the attempt count increases. That is intentional because the next user message is expected to answer this question. If the user replies with scan preset, the graph can resolve the query. Before searching the manual, it should clear pending clarification state. The old question has done its job. Keeping it around would make the next turn harder to reason about. If the user keeps answering with this, it, or the thing, the graph should not ask forever. After the limit is reached, the graph returns a useful fallback, clears pending clarification, and reaches end. This path ends the loop instead of preserving it. This is the important part. The ask path and the fallback path both reach end. But ask and wait should save pending clarification, while limit fallback should clear it. Same control flow marker, different memory policy. The boilerplate is wiring a state type, adding a conditional edge, compiling with a checkpointer, and passing a thread ID. The developer-owned core is deciding which fields survive each path, when stale state is cleared, and how to prove the graph cannot get stuck in an endless clarification loop. You can test this without a real retrieval system. Send a vague question, assert pending state survives. Send a clear answer, assert pending state clears before search. Send vague replies until the limit, assert fallback happens and direct search is not called. That is a state contract, not a prompt trick. End finishes the run. Your state policy decides what the next run remembers. For production agents, draw every path to end, write down what should survive, and test that the checkpoint state matches your intent.